All right, let's correct your answers to the projectile and orbital motion reading questions. These were the questions that you read or you answered after doing the readings about projectile and orbital motion. First question, what is projectile motion and when does it occur? Well, a projectile motion, and I'm going to do with many of these, I'm going to do little pictures as well as my written answer so that it's as clear as possible. So a projectile, when we think of a projectile, we can think of something that, is falling to the ground like this, or maybe it's going like this, or maybe it went up and down like that. But the key feature here is that projectile motion is when an object has some horizontal motion and is accelerating downward Now accelerating, meaning that, so even here, when it's going up, because it's slowing down, the acceleration, the force is still going down. So the acceleration is down even though it's going up because it's slowing down, and then the acceleration is down on this side because it's speeding up as it approaches the ground. So projectile motion, when an object has some horizontal motion and is accelerating downward because gravity is the only significant force acting on it. Now, why is it moving horizontally? And I could go that way too. Why is it moving horizontally if gravity is the only force pulling on it? Well, there was something that happened. Maybe it got thrown, or like in our simulation there was an explosion or something. There was a force that gave it some initial horizontal motion. But once it started moving, that force was gone. But it continues moving horizontally because, as we know, an object in motion will remain in motion unless acted on by an outside force or unbalanced force. All right, number 2. How might knowledge of projectile motion help you shoot baskets in basketball? Well, as we know, basketball involves the basket. And if you throw a basketball really hard so it doesn't have much curve to it, it's not going to be able to go in the basket. So to get the ball in a basket, you have to give it a curve. So when you shoot the basket, you are basically trying to put it at the right angle with the right initial speed so that it will have the arc. So the knowledge of projectile motion learning about the things that affect the curved or parabolic. Maybe use parabolic because that's more accurate. So now the parabolic path, which is, it's a result horizontal motion and vertical motion will help you achieve the right arc to get the ball through the hoop. All right. I think I made that a little bit more wordy than I had planned. So, but anyway, learning about the things that affect the parabolic path of the ball, like the angle you throw it at, the initial speed that you give it. So the parabolic path is the result of the horizontal motion, which is constant, and the vertical motion, which is accelerating downward, will help you achieve the right arc to get the ball through the hoop. All right, next question, which switches topics, and we haven't talked about this much yet, but what is orbit and orbital motion? Well, when you think of orbit, you think of some object, and you think of another object that's going around it, you know, in something close to a circle. So an orbit is the path one object is taking, around another object due to the combination of its horizontal speed and the gravitational acceleration towards that object. So this is the cool thing. Like, I find the idea of an orbit fascinating because essentially something in orbit is constantly falling, right? This thing is falling, but because towards the planet here, like if this is a planet, and let's say that's a moon or a satellite or something, or that could be the sun and not a planet. It's constantly falling, but because it's moving this way, as it falls, it's actually falling in a curve that winds up matching the curve of the thing it's going around. So it never actually gets closer because as it falls, the part of that planet where it's falling over next is actually curved around and is further away. Because if this kept going straight, it would be getting further away from the planet, right? But since it's falling this way, it winds up being a similar distance all the way around, and it goes around. So objects that are in orbit it's like a projectile that never actually makes it back to the ground because the ground keeps moving. So in a way, I'll add a little note here which will explain why orbital motion occurs even more. Orbits happen when the descent of an object is matched by the curve of the object it's going around. Now there might be a lot simpler ways to write this. It seems I'm a little wordy at the moment. As long as you have these main ideas. So let's say the one object is going around another object, that's an orbit, and it happens because there's a horizontal speed in combination with gravitational acceleration that gives the path a curve, and then that curve actually kind of matches, so it never actually gets closer to the ground even though it is a projectile that is accelerating due to gravity. All right. So in addition to the moon, artificial satellites also orbit the Earth. What factors do you think must be taken into account to ensure that a satellite keeps orbiting Earth rather than falling back to the Earth's surface? Well, if we look at this, there's two primary considerations here. There's like how much gravity is it experiencing based on how the distance they're away. So the distance the satellite is from Earth affects how much gravity it experiences. So remember the inverse square law, right? The further you away, if you double the distance away, you actually cut the amount of gravity in by a fourth. The distance the satellite is from Earth affects how much gravity it experiences. And the horizontal speed must be proportional to that gravity just right to create the curved path. So you've got, so if here is the surface of a planet, here is the satellite, it's got the force of gravity, it's got its horizontal speed, and that, the combination of those Actually, this should probably be a little bit longer because we want it to, we'll create the curved path. All right, sorry about the not so perfect drawing. Okay, Earth is closer to nearby planets, including Venus and Mars, than it is to the Sun. Why don't these other planets pull the Earth toward them and cause it to veer off its orbit around the Sun? This question is actually asking you to conjure up some of what you learned about gravity, and that we've already hinted at, that there are certain things that affect how much gravity. And one of those is Newton's law, Newton's law of gravity states that both mass and distance affect gravity. While Venus and Mercury are closer than the Sun, they are millions of times smaller. Both Venus and Mercury are smaller than Earth, and in the Earth, you can fit 1 million Earths in the Sun. Their smaller mass results in insignificant gravity relative to the Sun. Okay, and it's important to note that some planets actually do affect the path of other planets. Venus actually does affect the path of Mercury. They're close enough to each other. There was a blurb in like a little weird thing that scientists were trying to explain about Mercury's orbit that they couldn't for a long time until they had the mathematical tools about gravity to explain it. Neptune was actually discovered because they were looking at the path of Uranus, and there was something there. It would fluctuate at certain places, and based on gravitational formulas, it seemed like there should be another planet out there that was actually pulling on Uranus at different points. And so they figured out where in the sky that thing should be based on the gravitational pull Uranus was experiencing. And sure enough, they found Neptune. There was another planet out there. And so it was the math that actually led to Neptune's discovery. All right, so there's the answers to that, to your reading questions. Remember to go back over these, use them as to study for the quiz and to generate materials to study. All right, take care.